Hello, good day, and welcome to RSC Student Support Program. This is an initiative that's a collaboration between RSC and the Caribbean Principals Association of Secondary Schools, through which we are hoping this could extend throughout the region to support students who are writing the CXC examinations this year. RSC is a non-profit organization that's based in Trinidad and Tobago, and RSC stands for Restore a Sense of I Can. Our motto is Effecting Change Through Education and Technology. We started in Trinidad and Tobago quite a number of years back, and we have since extended our reach and support through countries throughout the Caribbean. And a huge part of this is through the collaboration of the Caribbean Principals of Association. This initiative, Adventures in Academics, is designed to support students who are writing the CSEC examinations and will be giving support in quite a number of areas. The first thing we'll be doing will be webinars that will be scheduled at fixed times. However, you can look at a repeat 24/7. It's going to be available 24/7, so students can repeat the webinars. In addition to that, there'll be quite a number of quizzes. These will be like multiple choice questions, and you can come back and do it over and practice. It's going to be self-marked. In about 2 weeks after doing the quiz, we will be putting up solutions that you can look at as videos, so you can see wherever you need support or help. In addition to that, there's going to be a live forum where, should you have any kind of issues, you can just go onto the forum and you can type your questions, and your forum will be answered by a number of volunteers or supporters, teachers, principals, past students, university students. In addition to that, of course, we will have tutorials. These tutorials will be small groups of about 10, 15, 20 students. You'll be able to come on live, and in the tutorials, you'll be able to ask your questions and have discussions with students in other countries in the region. Today, we're going to start off our presentation on our training with a topic called sets. But before I do that, what I would like to do is share with you where the content is coming from today. So let me just pull up a website that I would definitely like you all to check out. It's called fastpassmath.com. Fastpassmath.com content was developed by Dr. Shirin Khan and Dr. Fayed Ali. These are two stalwarts in the world of mathematics. And in fastpassmath.com, you can get past paper solutions for paper 2, add math past paper solutions, a study guide, and a whole bunch of other resources. What I want to focus on is the math study guide. And it's from the math study guide that you can download the notes for today's session and a whole host of other sessions. Today, we're going to do set theory. And from FastPass Math, absolutely everything you need to know about set theory, you can download this as notes. What we will do is, in addition to having this downloaded as notes, we'll put it up today as a downloadable file, so you can download the files straight off the webinar jam. I'll put that as soon as the video starts. So pull out your pen and paper, and let us start with the first lesson in set theory.
Set theory is a branch of mathematics that involves collection of objects. When objects have a common characteristic, they form a set. In describing a set, we use language that is clear so that there is no doubt in identifying its members. A set is a clearly defined collection of objects. Some examples of sets are as follows: the set of vowels of the English alphabet, the set of planets in our solar system, the set of black cars, the set of boys on the school's football team, and the set of girls in Form 5 at school. The first two examples are readily identifiable and can be listed. The set of black cars can also be identified even though we do not have information about all its members in terms of their location. What is important is that we can differentiate between the cars that belong to the set and the cars that do not belong to the set. The members of a set may be unknown, but once the description is not vague, it is well defined. When describing sets, we use curly brackets to replace the words "the set of." For example, the set of all the whole numbers from 1 to 10 inclusive is written like this, where the words "the set of" is replaced by curly brackets. The set of figures bounded by 4 straight lines is written like this, and the set of multiples of 5 is written like this. Let us look at the example. Does each of the following describe sets? A. Tall girls in Form 6. B. Girls in the school choir at Valley Government. C. Men who can sing well. And D. Boys who are good at sport. Only B is clearly defined, and hence only B describes a set, which is girls in the school choir at Valley Government. A, C, and D that describe tall or who can sing well or good at sports are all relative terms and not clearly defined. The statements A, C, and D can be reworded to describe sets. For example, instead of saying tall girls in Form 6, we can say girls who are over 160 centimeters tall. Instead of saying men who can sing well, we can say men who have auditioned for the church choir. And instead of saying boys who are good at sports, we can say boys who are members of their school cricket team. Each of the above statements is now clearly defined and describes a set. A set must be defined in such a way that there is no hesitation in deducing whether or not an object belongs to the set or does not belong to the set. Every collection is therefore not a set. A set is usually named using a capital letter. If we are speaking of the set of students in a school who study Spanish, then we may choose to name the set S, where S is described as follows. S is the students at our school who study Spanish. The following are examples of sets named by letters of the alphabet. A is multiples of 10. B, words that begin with the letter P. C, members of the school's football team. And D, red sports cars.
Now let's talk about the number of elements in a set. The number of elements in a set, let's say A, is called the cardinality of the set, and it's expressed as n of A. For some examples, the set A containing M, N, and P has 3 elements, or n of A is equal to 3. The set B, containing cherries, plums, mangoes, and oranges, has 4 elements, or n of B is equal to 4. And now let's go on to talk about empty sets. If a set has no elements, it is called an empty set or a null set. For example, if all the students in a class are taller than 120 centimeters, then we can define an empty set, let's say G, as the students in the class whose heights are less than 120 centimeters. Since there are no members in the set G, we say that the set G is an empty set. The following are some more examples of empty sets. The prime numbers from 8 to 10, days of the week that start with the letter L, and integers that lie between 10 and 11. Finite and infinite sets. If a set is comprised of a countable number of elements, it is called finite. If a set has infinite number of elements, then it is called an infinite set. It is not possible to count the number of elements in an infinite set. Hence, it is not possible to state the cardinality of an infinite set. Even though we may think of the cardinality of an infinite set as being infinity, infinity is not really defined as a countable number. The null set, or the set with no elements, is considered to be a finite set and has a cardinality of 0. So let's look at some examples. An example of a finite set may be the vowels in the alphabet, that is A, E, I, O, and U. Now, as you can see, there's only 5 elements in the set, and so the set is finite. An example of an infinite set may be the multiples of 3. There are countless multiples of 3, and so the set is infinite. Notice that in this set, there are 3 dots at the end that indicates that the elements of this set continue forever. Now let's look at set builder notation. Set builder notation is a simple and convenient way of describing the elements of a set without actually listing out all of its members. This is especially useful for a set that has large or infinite number of elements. Set builder notation is also useful to describe an interval on the number line comprising of real numbers. Sets comprising real numbers are examples of infinite sets that are impossible to list, and thus set builder notation is absolutely necessary in such situations. So using set builder notation, we can describe elements like this. The set of all values of x, such that x is greater than 5, and x is the member of the set of integers. And so the set builder notation for this is shown. The set of all values of x, such that x is greater than 5, and x is the member of the set of integers. Another example is the set of all values greater than -2 and less than 2. So this is shown in set notation here and also on a number line. So in summary, we can describe sets in 3 ways. Firstly, we may use words. For example, the set of multiples of 2. Then, we may list out its members in brackets, as seen here. And finally, we may use set builder notation, as seen here. Universal sets. Sometimes it is necessary to classify a set as belonging to a larger or more inclusive set. For example, the set of capital cities in the Caribbean can be said to belong to the set of capital cities throughout the whole world. So universal sets are not unique for a given set, but in all cases, members of a universal set must contain all members of the set we are making reference to. The universal set can be represented by a capital U or this symbol. Sometimes we may be asked to construct a universal set for another given set. For example, if we are given the set rectangles, squares, trapezoids, and kites, we may get the universal set quadrilaterals. Or if we are given the set 2, 3, 5, 7, and 11, we may get the universal set prime numbers.
Okay, so that was set theory part 1. Remember to download the notes or go to fastpassmath.com where you can download the notes on this topic and other topics and past paper solutions. Also remember to come back to the site and do the multiple choice questions because it's all about practice and practice and practice. So see you in our next session that's going to be uploaded shortly.